variation in magnetic moment, variation in magnetic moment due to cutting of bar magnet, due to cutting of bar magnet. Suppose here we have the bar magnet of pole strength M. This is having the pole strength M. This is the south pole. This is the north pole. And the length of this magnet is, magnetic length I am considered the 2L. Okay. So this bar magnet magnetic moment, you know, it is existing always in fixed direction from south pole to north pole. So its magnetic moment I am taken, that is equal to M into 2L. Now this magnet, this bar magnet, I can cut into the two parts along the axial line. So this line is so-called axial line. What is the axial line of the bar magnet? The axial line of the bar magnet is passing through the center of the magnet and as well as passing through the poles of the magnet. So here now I am cutting to this bar magnet into two equal parts. Two equal parts. Actually I am making here perpendicular to this axial line. This is axial line of bar magnet. So now I am cutting to this bar magnet into two parts in perpendicular direction of axial line into two parts. This is part 1, this is part 2. You know, based on the theory of magnetism, based on the molecular theory of magnetism, every part now it is acts like a magnet again. Now this part 1 is acts like a magnet, part 2 is acts like a magnet. Why? Because same, according to the molecular theory, the electrons of these revolving atoms are possessing the magnetic moment. So now it is acts like one magnet, it is acts like one magnet. So therefore now I want to find these two pieces magnetic moments. Okay, so therefore I am representing here, after cutting off this magnet in perpendicular direction to axial line, this is part 1. This part 1 pole strength is, this is S and this is N, right? And here this is a part 2. Pole strengths are same pole strength. Pole strength is same, but length is changes here. Here this, now this is becomes a small magnet when comparing with this one. What is its length here? This total 2L length is dividing into two parts now. This length is now half of the total length. So I am taking this is 2L by 2. Now this part 1 is a bar magnet of length half of the initial length. Similarly part 2 is also a magnet of length half of the initial one, 2L by 2. So now these two pieces are acts like the two magnets, two bar magnets, but their lengths are decreased to half of the length. So pole strength is same. Whatever the pole strength here, these two poles are having the same pole strength. Here, these pieces also having the same pole strength, but length of the magnet is decreasing off. So now the new magnetic moment, the magnetic moment of these small pieces or the new magnets, I am considered M dash. Okay, M dash is equal to here. So by definition, pole strength into length of the magnet. Length of the magnet is here 2L by 2, 2L by 2. So therefore, the smaller magnet's magnetic moment M dash is equal to, you are getting here M into 2L by 2. M into 2L, this is the initial magnetic moment. Initial magnetic moment is M. So therefore, the pieces magnetic moment, the new magnet's magnetic moment, after it is cut into the two parts. Now these two parts are acts like the two magnets. two short magnets, their magnetic moment m dash is equal, now we are getting m by 2. So here in this case, we are cutting the magnet into two equal parts in perpendicular direction to the axial line. This is axial line of the magnet. So with respect to the axial line of the magnet in perpendicular direction, we dividing into two equal parts, same length, two equal parts. So obviously this length is half of the total, this length is half of the total. Therefore new magnetic moment. Now this piece acts like one magnet whose magnetic moment is m dash. This piece acts like a magnet whose magnetic moment is m dash. So now here this is a case of bar magnet is cut into the two equal parts in perpendicular direction to its axial line. Now you tell me, suppose now I am dividing this bar magnet into x equal parts. So now this is our bar magnet. This is the south pole. This is the north pole, and this is the total length of the magnet whose pole strength is m. Okay. This is the center of the bar magnet. Now this bar magnet I am dividing into in perpendicular direction of axial line x equal parts. This is part 1. This is part 2, part 3, part 4, like that. We are breaking into how many parts here? X equal parts we are dividing. Okay. So when here now this is cut into x equal parts. Now every part length becomes what? Total length is 2L. This 2L length now you dividing into x equal parts. Length of each part is 2L by x. 2L by x. Now this part is acts like a magnet. This part is acts like a magnet. So that new magnetic moment. I am considered one such small piece. That small piece is pole strength. This is S, and this is the south pole. This is the north pole. Okay. The length between the south pole and north pole of this small piece is how much you are getting here? Total 2L length. You dividing into x equal parts. Therefore, the length of this small magnet is you are getting 2L by x. Therefore, its magnetic moment I am considered the m dash. Now m dash is equal to, you are getting here, m dash is the new magnetic moment of this small piece. Okay, sir. So the new magnetic moment of this small piece is you are getting here. So pole strength does not changes. Why? Because pole strength of the material is depend on area of cross section. Pole strength m is depend on area of cross section of material. Area of cross section is for every piece is same. Therefore pole strength is same. So this is m and this is m, but length is here 2L by x. Therefore magnetic moment m dash is equal to m into length here 2L by x. Therefore m dash is equal to m into 2L by x. Therefore m dash is equal to, you are getting m by x. Are you getting the point here? When bar magnet we are cut into parts in perpendicular direction to the axial line, the magnetic moment, how the magnetic moment is going to change. This is initial magnetic moment, this is final magnetic moment. This is after cutting the new magnetic moment is I am taken m dash. M dash, when first case I am cut into two equal parts. In the next case I am considered into x equal parts. When I am cut into x equal parts, each part magnetic moment. Similarly, two parts. Clear? This is the case 1. In the case 1, we are cutting the magnet in perpendicular direction to axial line. Okay. So this is a case one. Magnet is cut perpendicular to the axial line. Magnet is cutting perpendicular to the axial line. Magnet cutting perpendicular to axial line. This is the first case I am considered. Can I go for the next one? Okay, okay. So next case, I am going to cutting the magnet in parallel to the axial line. So when magnet is cut into pieces in axial line along the parallel to axial line, how the magnetic moment of the magnet each piece is varying. Okay, the next point is the given magnet we cut into the pieces parallel to the axial line. Second case, magnet is cut into pieces parallel to axial line. Okay, here this is a given bar magnet. Suppose this is the south pole and this is the north pole. The pole strength of these poles is M, and the length of the magnet is here. I am considered the 2L. This is somewhere center. Now this magnet I cut into the two parts parallel to axial line. This is actually axial line now. This is axial line. So I am cutting to two equal parts axial line. So exactly like this. Now this is I am taken. This is a part 1. Now this is a part 2. So cut into two parts exactly along the axial line. So then now the part 1 is acts like a magnet. Part 2 is acts like a magnet. So I am representing here. This is the part 1 and this is the part 2. Okay. Here part 1 and part 2, length of the magnet is same. Magnet length whatever this one, this is also having the same length. Length is same, but what is changes is here magnet area of cross section changing here. The pole strength, M is the pole strength of the magnetic material, pole strength of the magnet or magnetic material is depends on its area of cross section. When area of cross section is more number of atoms in unit volume, then magnetic moment is more, pole strength is more. So pole strength of a magnet depends on area of cross section of a magnet. Here initially this is the bar magnet having the area of cross section, suppose A area of cross section. Now it is dividing into half. So therefore its area of cross section now becomes A by 2. This is, so obviously this pole strength is new pole strength, that is I am taken S dash, this is N dash. Why I am taken separate poles here? Its pole strength is different, that is M dash. Why? Because area of cross section is changes, pole strength is changes, therefore I am taken that is M dash, right? So now this is its magnetic moment from south pole to north pole is M dash. Okay. Similarly here this is south pole to north pole, M dash. Now I want to find this M dash. Here first of all this initial bar magnetic moment M is equal to m into 2l. Okay, for our convenience, pole strength is depend on area of cross section. Therefore, pole strength is equal to, I can write K into A. This bar magnet, initial bar magnet pole strength in terms of area of cross section, this is equal to K into A. Okay, this is into 2L. Okay, you consider this is equation 1. Now, when coming to here, after it is cutting into two parts, every part area of cross section is A by 2. Pole strength is depends on area of cross section. Therefore, m dash is equal to, I can take m by 2, or otherwise you can keep as it is. So m into 2l. So now this new pole strength is m by 2. Why? Because area of cross section is varying. Exactly, it is decreases to half of the area of cross section. So therefore, new magnetic moment m dash is equal to m dash into length. Length is the same length only. Whatever the length here, same length only. So m dash into 2l. Therefore, m dash is equal to small m dash into 2l. Small m dash is equal to here m by 2 into this is 2l. So again here you are getting here m dash is equal to m to l. M to l is initial magnetic moment capital M by 2. So when here the bar magnet is cut into the two parts parallel to the axial section of moment. So here m dash is equal to m by 2. Now axial line we got bar magnet is how much? So then m dash is equal to what here it is dividing into x parts now. So now new pole strength is m dash is equal to m dash into 2l. M dash new pole strength. Now you can check the audio and video. You can check the audio and video. Okay. So here we are along the axial line, the bar magnet we cut into y parts. When it is cut into y parts, area of cross section is reduced by 1 by y times. So therefore, pole strength is small m by y. Then new magnetic moment m dash is equal to m by y. Okay. This is a second case. Magnet is cut into pieces parallel to the axial line. Okay. Right. Now the next case is magnet cut into the pieces simultaneously parallel to the axial line, perpendicular to the axial line. In that case, what is the new magnetic moment of each piece? Okay. So the next case is case 3. Magnet cut into x pieces perpendicular to axial line, and y pieces parallel to the axial line. X pieces perpendicular to the axial line, y pieces parallel to the axial line. Then what is the new magnetic moment of every piece? Or what is the new magnetic moment of smaller one? So this is a given magnet. This is the south pole. This is the north pole, and pole strength is small m, and the length of the magnet is 2L. The magnet cut into X pieces perpendicular to axial. So the total 2L length is cut into X parts in perpendicular direction. 1, 2, 3. So like that, it is cut into how many parts? X pieces. So total it is X pieces in perpendicular direction to the axial line. Similarly, in parallel to the axial line, how many pieces? Y pieces. So this is first piece. This is the second one, third one, and so on. This is the fourth one, like that, Y pieces. So parallel to the axial line, it is cut into the 5 pieces. So then every small piece is now acts like a magnet. The magnetic moment of that small piece. Now I am considered one such small piece whose pole strength is I am considered m dash, and whose length, this is a s dash. This is small piece poles, south pole is I am taken s dash, and this is I am taken n dash. Pole strength is m dash, and this length is, what is the length of this small piece? Total 2L length is dividing into X parts perpendicular direction. Therefore, this length is 2L by X. Similarly, in parallel direction, it is dividing into Y. So, pole strength m dash is equal to, you get m by Y. Okay. So, now the magnetic moment of this small piece is from south pole to north pole, m dash. This small piece magnetic moment is, now I am considered the m dash. M dash is equal to its pole strength, m dash into its length. Length is what here? Its length is 2L by X. M dash is equal to m by Y. So m by Y into 2L by X. So therefore, new magnetic moment of a small piece of bar magnet, that is equal to, you are getting here, m into 2L by X into Y. M into 2L is what? Initial magnetic moment of actual magnet, that is m into 2L, initial bar magnet magnetic moment. Therefore, m dash is equal to, you are getting m by xy. M by xy. Okay. I think all of you understood how the magnetic moment of the magnet is going to change when it is cut perpendicular to axial line, when it is cut parallel to the axial line, simultaneously both perpendicularly and parallelly. So here this is a case, perpendicularly X parts we are dividing, parallelly Y parts you are cutting. In that case, the new magnetic moment of every small part is again acts like a bar magnet, a small magnet whose magnetic moment is m dash here. I hope all of you clear. This is how the magnetic moment is varying when it is cut in perpendicular direction, parallel direction, and combined case. Okay, right. So these are the 3 different cases of calculating of new magnetic moment of the small magnet. Now based on the how the magnetic moment is changes when magnet is cut into parts. Based on this varying of magnetic moment when magnet cut into parts, based on that factor, next I am going to the next point here. Same again, the same point, that is varying of magnetic moment. Varying of magnetic moment. Varying of magnetic moment when bar magnet bent into another form. Bent into another form. So when it is bent into another geometrical form, the magnetic moment of the magnet, bar magnet, how it is varying, we have to calculate. Okay, we have to find here. For example, here we have a bar magnet. Suppose this is a bar magnet of pole strength M. This is the south pole, this is the north pole, somewhere between them center, and this is the length of the bar magnet. I am consider this is 2L. Now this bar magnet I bent into the, first I am cut into 3 equal parts, or I am dividing into 3 equal parts. Then that 3 equal parts I am arranging as like this. This is the part 1, then this is the part 2, then this is the part 3. So first of all here I divide the, I am bending into 3 parts, 3 equal parts in perpendicular direction. 3 equal parts in perpendicular direction. The either sides of the parts I am bent into vertical. I am bent into the vertical. So actually here this is south pole, this is north pole. So therefore here you get this is the south pole. Here this is the north pole. Now for this one, this is the south pole. This is the north pole. Now for this one, this is the south pole. And this is the north pole. Okay. What is actually here? The bar magnet, given bar magnet of magnetic moment M, that is M into 2L, is in this direction here. This bar magnet is bent into the U shape by making 3 equal parts. So what is the new magnetic moment of this U shape magnet? Now this bar magnet is bent into another shape, U shape. How you are converting this U shape? You dividing into 3 equal parts. The either sides 2 parts you bend into vertical shape. Then you are getting the U shape. So then what is the magnetic moment of this one here? So this is the total length is dividing into 3 parts now. So this is cut in perpendicular direction. When cut in perpendicular direction, what changes, what constant? When the magnet is cut in perpendicular direction, what you are getting here? Or what is the magnetic moment of this U-shaped magnet? Magnetic moment of this is a U-shaped magnetic moment. This is the initial bar magnetic moment. So what is the M dash? Here M dash is the magnetic moment of U-shaped magnet. Now vector, M bar is a vector quantity. This vector and this vector is cancels. So only resultant south to north you have. This is the resultant magnetic moment. That magnetic moment is equal to this one. So therefore M dash is equal to M by 3. So what is the point here? Okay, a video is actually there is some problem. We are unable to rectify that problem. So we will stop here. And Monday you have the holiday. So therefore Mondays there is no classes. Continuation you have the continuous 3 days you have the holidays, Saturday, Sunday, Monday. Okay. We will again will back on Tuesday, right? And you remember regarding the Sunday exam, whatever you have the any doubts and anything you have, you can interact with me in the WhatsApp group. I can respond. If at all you have any doubts during your preparation, you can post on WhatsApp group. Then I can interact with you, and you can make directly also, right?